Welcome to this explainer on computational physicalism, a seriously fascinating theoretical inquiry into human and AI intelligence.
Okay, let's dive into this structural blueprint. We're exploring foundations, computability, existing theories, implementation, ethics, and claim scopes.
Our foundation is the modest physical Turing thesis. We're strictly avoiding debates about unmeasurable consciousness or qualia here.
Whether it's your 20-watt brain or a megawatt data center, both share identical physical laws and strict resource constraints.
So, intelligence is essentially defined by required computation. Functional equivalence is purely about getting matching inputs and outputs.
And this brilliantly illustrates how finite human cognition makes mathematical realities, like universal approximation and pack learning, possible.
Intelligence scales up hierarchically. Going from pattern matching to discovery separates theoretical computability from what's actually practically feasible.
By focusing literally just on computation, this beautifully contrasts with existing theories like integrated information or global workspace.
Look, scaling laws and emergent abilities aren't magic. They're basically just observable measurement thresholds being crossed, right?
Let's move to and see how this builds a three-layer architecture, from basic actions to complex emergent behaviors.
Creativity isn't some mystical inspiration. It's actually engineered through strict constraints and aligned using inverse reinforcement learning.
This sets up a dependency-based roadmap, pushing us from establishing foundational tech today toward total human-AI coevolution.
So, the crucial point is that human dignity relocates from raw intelligence directly into physical embodiment and social history.
Meaning, society itself becomes computation, education shifts to metacognition, and democracy literally functions as a distributed computational system.
And remember, energy isn't just an external limit. It is an absolutely core design variable in computational physicalism.
For compliance professionals, we must neutrally distinguish between binding laws like the EU AI Act and voluntary frameworks.
Now, what's really interesting about this slide is the strict review gate separating established mathematical claims from mere hypotheses.
So, to wrap this explainer, how will you measure your own computational constraints moving forward? Thanks for watching.